He's worked at Microsoft Research under the mentorship of Eric Horvitz to detect misinformation. He has collaborated with Eleuther AI to build state-of-the-art symbolic music models. Finally, he has collaborated with the MIT Plasma Science and Fusion Center to model disruptions in nuclear fusion reactions. His work has received numerous awards, including 2 outstanding paper awards at EMNLP 2024, 1 Spotlight Award at ICML 2024, and an outstanding paper award at NACL 2022. He's fortunate to be supported by a 4-year Bloomberg PhD fellowship. So please welcome Alex, and we're very excited for your talk.
Thank you so much, Katie. And thank you so much, everyone, for being here. A little context for my talk. I'm going to be giving a job talk next week, so it kind of snuck up on me, and I've been frantically preparing. So I really appreciate any comments and questions you might have, and also any tips you might have. It's going to be really, really helpful for me when I'm preparing for next week. So. I'll take it away with further ado. Please excuse some slides that are not the most beautiful. As I said, I've been working on this really hard, but it's almost there. Um, okay, so today we're going to be talking about planning in creative contexts. I'm going to get to what that means, but first let me give you a kind of motivating example. So I remember, as Katie said, I used to work at the New York Times, and I can trace back to the day that I got really interested in this path. It was April 21st, 2012. I was reading this news article, and the article was about bribery in Mexico and how Walmart was bribing Mexico to build big stores. And it was shocking. It made me really mad. It made me really angry. But then I saw the next day the reaction that occurred in the world was immediate. Um, Stocks fell, people left, inquiries were opened, the Mexican government launched an inquiry, and eventually the US slapped a large penalty on Walmart. So, as shocking as the story was, the I felt a sense of awe at the power that a single person with a pen and paper could bring into the world just by making this information public. And indeed, lots of academic research has found that more press freedom causes less corruption in society, uh, and the money spent by newsrooms reaps a magnitude more social benefits in terms of good society and good government. So it was a dream of mine to work at the New York Times, and I got really lucky, and I worked there for 4 years doing things like building the recommendation engine that serviced millions and millions of users with David Bly and Chris Wiggins and Chong, um, and doing reporting in the newsroom that, like this story, for example, that tracked how our editors and reporters moved around covering the election. Um, so not only did this work impact our readers, but it led to fundamental changes in the newsroom in how we covered politics. But this story is not as simple as that, because in the world, in the US and in the broader world, journalism is really suffering. So from 2002 onwards, the revenues that newsrooms were bringing in dropped by about 80%. And in the US, we're in a situation now where 50% of the counties in the US are considered news deserts. So they have 0 or 1 newspapers. And the story is largely the same across the world. So a natural question to ask is, what can be done? Now I'm going to focus in on one area of journalism, and we're going to continue this for the entire presentation. Um, and we're going to consider sourcing. So what is sourcing? Sourcing is the process by which a story idea is backed up by documents and voices and experts, until a final story is published, right? It's actually one of the most time-consuming parts of journalism, and journalism in general is in a very, very quick timeline. So reporters typically have about 6 hours to publish their pieces. Um, about 5 to 7 sources are used per article, and this takes a lot of time. It takes about 30% of this process. It's a huge learning curve. And so beyond just being expensive and time consuming, the effort required to find sources and good sources results in a lot of disparities. So as journalists have less time to report, they tend to rely on less diverse sources. So a lot of research has found that news stories rely on shockingly undiverse voices. 70% of articles quoted sources are male. 79% were non-Hispanic white. And the tighter the deadline gets, the less civilian sources are used and the more PR sources are used. So as newsroom budgets contract, the quality of news decreases in terms of the sources being used. What if we had a way to help journalists, to help them find sources, to understand the needs of a story, and then go out into the world and make this task easier, shorten the amount of time it takes to find these sources. We argued in this paper that doing so can help us not only lower the cost of journalism so that we can expand into some of these areas where journalism has contracted, but as highlighted in the previous slide, anything we can do to make this task quicker and easier can also improve the quality of journalism. So what are the challenges here? Why is it very difficult? Why is this a very difficult task? Well, I'm going to move away from journalism for a second and give more of a toy example here. What does Why does journalism require planning, and what does planning in creative contexts mean? First of all, what is planning? I'm going to define planning here as any kind of reasoning about an action space. So here is a pretty simple depiction of what reasoning might look like, kind of a higher level instructional plan about how to cook, say, fish stew. What is a creative context? Like cooking, like putting together a fixed stew, um, a creative context is any task where the reward function isn't really clear. Are we trying to optimize for nutrition here, or taste, or um, some other aspect? As humans, we usually fuzzily move towards something that some kind of outcome that we desire. But because we can't really explicitly formulate this reward function, it can be very difficult to optimize and train a machine to move towards this. Finally, where does this show up? Where does creative planning show up? Well, as I've indicated, journalism is one area, and there are several obvious other areas like writing and science and music. But I would argue actually that most human tasks follow this general guideline. Most human tasks don't really have clear reward functions and require some kind of forethought or reasoning about what humans are going to do. So how do humans typically learn to plan in creative contexts? Let's move this metaphor forward a little bit. Jay, do you have a question?
I do. So when you talk about there not being a clear reward function, in a creative context, is there a reward function? I mean, I guess is there? Could you just dig into that? Like, is there a latent reward function that we don't know? Or are there many reward functions, or is the reward function subjective? How do we actually typify this um, reward function if you're going to say it's not clear?
Right. I mean, I think that depends from task to task. I think it's a bit of a philosophical question. What we are going to argue going forward is that we can take steps towards learning like a very complicated reward function. Um, but I don't know if that entirely answers the question. I don't know if we will ever entirely replicate human processes in these doings. Um, but what we'll argue is that we can certainly come close, right? So there certainly is some kind of fuzzy reward function that we can approximate.
So I mean, like I guess just to the point of, well, the question is, can you, if there isn't a clear reward function, can you score creative output, in any way? And you're saying yes, there is a way to score them, even if the reward function is unknown and unclear. And I'm just trying to understand that. Like, you can make a bad fish stew, and you can make a good fish stew, but there isn't just one good fish stew and there isn't just one bad fish stew. So, when we get to these subjective kind of rewards or evaluations of creative outputs, how do we do that? And maybe, that's a complete distraction from your talk. I'm sorry if I'm going like off the rails here, but it is sort of like an interesting question to me since it's so important to the creative context.
I definitely agree with you. I really should clarify better. So we're going to move forward with the sourcing example, and we're going to see how sources are used. And that's definitely a creative context because there's many different ways you can use sources in news writing. Um, but I think that, if we were to observe combinations of sources at scale, we would see underlying patterns. So I think you could say the same argument about language modeling in general, or any kind of sequence prediction. Like it might seem like a futile task to predict sequences of words because there's bad sequences of words, there's good sequences of words, there's many decisions being made on a higher level. But like the story of autoregressive modeling over the past years has shown us that we can learn these highly complex human decision functions. Um, right. And that's the same end goal that we're trying to do here. So right. Did that address your question or not really?
Sure, I'll wait to see the rest of the talk, and we can always discuss it later.
Sure, sure. Okay, so let's take this metaphor a little bit further. Um, so when humans are making fish stew, we'll go through a sequence of steps. If we were to try to build tools that can understand these steps and that can execute these steps, what options are at our disposal? So we can follow instructions, but this can be very costly, and there's actually not much instruction data around. Um, every restaurant has its own version of fish stew. We can observe humans performing these tasks, but this is also extremely costly, and really hard to generalize. It's feasible to sit 10 humans down, 20 humans down, and collect a lot of data about their actions, but how well does that generalize? And then we can engage in trial and error learning, but this is also difficult without a clear reward function. What we're going to argue throughout the rest of this talk is actually that humans actually have a different way of learning these processes. So we all have a friend, we all know someone who can like taste a dish and like understand immediately what kinds of ingredients were used in this dish and how it was prepared. That's not me. I'm really bad at cooking and I have a terrible taste profile. But it's possible to just simply observe the final state, like the final stew that you're consuming, and reconstruct to some noisy degree, reconstruct the steps that happened in order to create that stew. And the connection to journalism is that a trained journalist can read a news article and they can understand the sequence of sources used, why these sources were used, and how they were put together. Indeed, this is similar to advice that we might tell our students all the time. If you want to become a better scientist, read more literature, right? Read more literature and understand the actions that the researchers were doing in behind the scenes. So this basic conceit forms a lot of the work that we're going to do. A lot is going to ground the rest of the talk. And this conceit basically breaks down into three parts. We have to prove three things to fully develop this. First of all, is this even possible? So is it possible to go from the final state, like the news article, and reconstruct the sequence of actions that were taken? If that is possible, then can we use these inferences to learn to plan like humans or learn to execute action sequences like humans would? And then finally, so that's these red arrows here. Can we progress through the different actions and learn these sequences of actions? And finally, plan adherence. Let's say we have a good plan. Can we make sure our AI systems actually follow this plan and use them in larger pipelines and larger structures? So as Katie mentioned, this work has won a number of awards, including Outstanding Paper Awards, Spotlight Awards, Best Paper Awards. Um, I've been generously supported by a PhD fellowship, and I've been directly involved in $2.7 million worth of grants that have built off of this work. I'm not going to get deeper into it until maybe the end, but in addition to journalism, this basic idea can be applied to science, and we are working with OpenAI to do a large-scale science replicability study by kind of reconstructing action sequences that scientists do. I'm involved with Ulether AI in a music project, and I'm working with researchers at UCLA and USC to apply similar methods in creative storytelling, legal writing, video scripting, and web navigation. Okay, let's start with oh, sorry. This work is it's a we're really excited about the direction this work is going. And this work brings together many different fields. So natural language processing gives us the tools to reason about latent action trajectories. Reinforcement learning gives us the tools to learn from these action trajectories. And finally, at the end of the day, we seek to impact humans. And human-computer interaction gives us the tools to understand how we are doing that. We are calling this field creative planning, and we have a tutorial coming up at NACL 2025 where we're unifying our work with the work of others in the community. Okay, so let's start with the first part of our outline. Is it possible to learn action sequences from just the final states? So we need to answer two fundamental questions in order to affirmatively move forward. The first question, is it possible to infer the sources that are used in news articles? And then if that's true, is there even a pattern to the way sources are used? So if the answer were no to either of these questions, I would argue it's not possible to move forward at all. And I think number two really gets to what Jay is asking. So if all humans are different and they all use sources in a different way, and there's no way to learn sequences of sources, then this is a problem that doesn't have any structure, and we cannot move forward at all. So we're going to show in a couple of slides how we would address that question. Okay, so for the first question, is it possible to infer sources? Some sources are extremely easy to infer. So we've actually already seen this in the beginning of the talk. Here's a source that was used in the Walmart article. And he has a direct quotative. So it's really easy to detect that this person was a source associated with this information. However, other sources aren't as clear. So for example, here's a sentence from a news article that a trained journalist can definitely look at this and say, oh, this is referencing information from the tourist office and the Hong Kong stock market. There's a very limited amount of places that this information can come from. And so, a trained journalist would be able to predict exactly what the original journalist used in this reporting. The same is true for either voting records or court records. This was actually a sentence about court defeats. So the court records in these three states had to have been referenced. So this is complicated. We can't simply take a rules-based approach because of all the different variations. So in order to address this question, we built an annotation interface and annotated 1,300 documents, annotating exactly what, if a sentence was sourced, we annotated exactly who the source was, as depicted in the news article. We found that, as I said, a rules-based classifier does not perform very well, and neither do either baseline approaches or zero-shot, few-shot GPT-3. So this is not something that's intrinsically part of pre-training, the ability to detect sources and reason about all these very nuanced indications that sources are used. However, when we do fine-tuning, we can nearly solve this problem. So GPT-3 fine-tuned gets a very high score at source recognition. Okay, so we can reasonably infer that a journalist used this set of sources. Now let's answer the second question. Is there a pattern to the way sources are used? We're going to answer this question in two ways. The first is to take a news article that has some set of sources in it, here represented as the yellow sentences and the blue sentences. And we're going to remove sentences in one of two ways. So we're either going to remove all the sentences that include one source, or we're going to remove other sentences that do not contain any source information. And then we can ask a very simple binary classification problem. So given an article, is this missing a source or is this not missing a source? It turns out that this is a learnable problem. So if we remove the source that has the most sentences or the primary source, we can reason with reasonably high accuracy about whether the source was ablated. This does drop a bit as we consider sources that are more secondary. They have less sentences attributed to them. And then finally, if we take any source in the article, we are doing worse, but we're still doing better than random. And we conclude in the paper that this is an indication that this problem does have structure. Finally, there's a second way to reason about sources. We're using here the news edits dataset, which won an outstanding paper award in NACL 2022. In the news edits dataset, we have collected every time an article updates with a new version and that new version is republished. We've collected that entire sequence of updates. So we can construct a learning problem here where we observe articles where sources have been added. And then we can ask, does article V need a source? And this again is a binary classification problem because we can choose articles that either had a source added or did not have a source added. And for the news edits trial, we similarly do pretty well. We actually do even better than kind of this any source ablation. So I'm going to show actually some more news edits comparisons. And these are not directly source related, but they do point towards structure and patterns in these human action sequences. And I'm going to show them for a pretty crucial reason, which is that we included human trials here with professional journalists. So we asked a number of questions about the way articles update. This first question, will this article update at all? So will there be a V+1? And here both models and humans are doing pretty well. And the second question, how much will this article update? So given article V, is there going to be 5 sentences added, 10 sentences deleted? Questions like this. And our models do worse for sure. Our performance is dropping, but actually the human performance is still really high. So again, these were professional journalists that were reasoning about linguistic, topical, event-based features about that they knew from their own prior knowledge about how articles update. And they're doing really well. So even if, as we show, we show positive results in our ability to model, but beyond that, we might still be missing things in our models. Humans are engaging in this very real reasoning thread, and they are able to detect structure in these latent human actions. Okay, so the takeaways from this section, remember we started with the question, is it possible to learn action sequences from final states, and do these have structure? Yes, we can infer sources that are used with high accuracy, and the pattern of this usage is highly predictable. Now we're going to move on to the next part of the talk. So given that we can reconstruct some of these action sequences, how can we use this inference to do better, to plan better with our AI tools? And can we construct better AI tools? Okay, so part 2, how can we learn human plans better with AI tools? In this work, which won an outstanding paper award at EMLP 2024, we start off with LLMs, off-the-shelf LLMs, and we seek to answer the question, how well does a sequence of recommendations made by an LLM compare with the actions that the human might have made in the first place? To answer this question, we collected a large data set of 250,000 press releases covered by 650,000 news articles. And interestingly, many of these press releases were covered multiple times. So we had a sense of multiple narratives or generalized action threads. As I covered in the last section, we have tools that can take in the news article and reconstruct the sources used by the human. So here we're showing how we used this prior trained model plus an LLM to reconstruct these general categories of sources, like an employment lawyer, an advocacy group, or an insider. Next, we took our LLM and we prompted it with suggestions like, what kind of sources should I use to pursue this story? In this case, the LLM might make, in this toy example, the LLM might make 3 recommendations, and we might say, okay, well, the angle doesn't match. Okay, this source matches this employment lawyer, matches this legal professor. They might give the same kinds of information, but these other 2 sources don't match at all. So overall, considering the entire action thread executed by the human, it has low overlap with the suggestions made by the LLM. These results broadly generalized across the data set we tested. So in general, we found that most leading LLMs at the time had a very low ability to recommend sources or source types, and that fine-tuning did help. So it did increase our accuracy a little bit, but not enough to really be used in any kind of a real setting. And then perhaps more interestingly, beyond their performance, was that the recommendations they made were significantly less creative than the actions humans ended up executing. So how am I defining creativity here? Creativity is defined on a 5-point scale, and we had human annotators look at each source, either used by the human or recommended by the LLM, and rank how different it was from the original press release or the original starting idea. As you can see, in general, humans use sources that are far away from the original idea that really take the story in new directions, whereas LLMs tend to use less creative and more kind of obvious sources. So I would argue that this has real implications. These systems are already being used in different ways, whether in journalism or other tasks. And the more that they are used at kind of the higher level of planning, the more impact they will have on the output, the more they will change the human trajectory. And it's really important to understand that these sources, that these actions need to align with human values and understand what those human values, what those humans' actions would be. Okay, but before we go further with any conclusions, we need to address kind of the fact that this setting is extremely unrealistic. We are comparing human actions that are made with full knowledge of the real world, with full interaction with these sources, against model recommendations that are made in a completely closed system. So in the follow-up work, we exposed the LLM to outside databases. We said, okay, if the source has some kind of recommendation, maybe you can go and find a source that matches this recommendation, and then use this knowledge to update its reasoning threads, and then continue to give better recommendations. So what is this doing here? This is really disentangling the sources of error in our previous experiment. This is saying, okay, can we separate planning deficiencies and reasoning deficiencies from a lack of world knowledge and from an inability to access the world? So to address this question, we processed the same large data set of news articles to extract all of the sources that were used in each news article, and we put these in a large database. And then we process the press releases to extract an initial query. And I'm going to show an example of what one of these action threads looks like, what an LLM action thread looks like. So it starts with the initial query here, what issues of racial harassment exist at the Fremont factory. And then it's able to query this source database. And it gets back several sources that actually were used in the news article, and then several other sources that might look similar but are irrelevant or were not used in the news article. It then issues a follow-up query, and the same thing happens, and it continues to issue follow-up queries. So what do we notice about this sequence of queries? I'm going to visualize this in a two-dimensional space. So the initial query is able to return some accurate sources, and then the follow-up query maybe goes off in a different direction, continues to explore the space. But then it does seem like the queries get a little stuck. So they tend to kind of circle around the same idea and maybe ask for slightly different kinds of sources. How does this compare to the way humans would explore this space? So this results in the score that we see here. Here's the interleaving experiment. So dense passage retrieval is our baseline, and the interleaving experiment improves slightly above this baseline. But as we can see here, we still have a lot of deficiencies with the interleaving experiment. How does this compare with the way humans would explore this space? So as we see here, the way humans choose sources around this space is not only more diverse, but it does seem to show some structure. So the human decided, well, I need to find these different types of sources. And then this source right over here required a confirmation. So they required another source that was actually very similar, that contained a lot of the same information in order to confirm what the source was saying. So this is our model here that we had introduced previously, that there's a database and there's a sequence of queries. But this kind of pattern displayed by the humans indicates that we are actually in need of some kind of higher level plan. We need some kind of higher level action sequence that helps us continue to explore this space and make reasoning statements about this space that is not captured by the LLM itself. The LLM is failing. So I'm going to show you the results of when we use a higher level plan. So if we introduce kind of the gold plan, the Oracle plan, what is our upper bound? We get a lot higher. And then if we take some approaches to planning, so we took kind of the simplest approach to planning here, which is an autoregressive approach, we are already improving above the interleaving experiment, the baseline LLM. But we certainly have more to do, and we certainly have more kinds of planning approaches to take. There's still a very important unanswered question, though. I kind of glossed over, what is this plan? So what is this sequence of actions? Here we defined a lower level schema, so a 10-dimensional schema, and we classified each source as one of these schema elements. And then the plan here was to learn a sequence of source types. So to learn the fact that a main actor is then followed by, say, background information or a confirmation. Okay, so our conclusions from this section are that current AI tools suffer from a lack of higher level planning, and that training higher order planners is promising. What we've explored in this section is kind of training a higher level small action space with a 10-dimensional action space. But this is nowhere near kind of the end of this pathway. We think, there's a lot more work to be done with exploring kind of O1 style approaches that might be learning more complicated and higher level plans. But we think that this is a promising start. Okay, so now let's transition to the third part of our presentation. And here we're going to ask the question, if this plan is adequate, if we have kind of the ideal plan, how can we make sure that we incorporate it into the news production process or any kind of downstream pipeline? So this work was Spotlight Award at ICML 2024. And like I said before, we are trying to answer the question, if we have the ideal plan, how can we use it in our news writing process in a downstream pipeline? And this becomes very challenging. So here I'm showing maybe one kind of typified plan. We might say, okay, we have the set of sources we want to use, and here is how we want to use them. So I first want to introduce this first source, then I want to introduce this second source, then maybe I want to compare them, and then I maybe want to end with this third source. And the standard way we might do this is to construct a large prompt that has multiple parts. So first, the introduction part is the first part, then the second introduction part is the second part. But as we might realize, having played with LLMs, the larger and the more complicated our prompt gets, the less likely the LLM is to actually follow each part of the prompt faithfully. So to address that, we introduced a new inference time technique called classifier-free guidance in language modeling. Classifier-free guidance introduces a new probability function that is the guided or controlled distribution. Here, WI is the next token, W minus I is the previous generation, and C is the prompt. And what we're going to try to do is take the kind of vanilla prompt condition language distribution. So this is what we would normally get out of an LLM. And we want to subtract, actually, the unconditional language distribution. So this is the likelihood of WI without any prompt. And the effect that this has on the logits of the guided and the controlled distribution is as follows. So when gamma is 0, we are relying on just the prompt condition language distribution, and the logits might stray from the original prompt. They might pay more attention to the previous continuation. But then as gamma increases, now the prompt is very, very important, and the effect of the previous generation, or W minus I, is lessened. So that's cool. That helps us adhere to prompts, and that helps us pay attention to prompts more. But you might be wondering here, I mean, we're not just talking about adhering to the whole prompt. We are talking about specific parts of the prompt. And to address this, we introduced a second distribution here, which we called the negatively conditioned distribution. Here we still have the prompt C, and then we have the negative prompt. And what this allows us to do is, at some point in our output, specify, oh, we want to be paying attention to the second part of the prompt, so that would be C, and all other parts of the prompt are going to be placed under C bar. Okay, so the C bar distribution is the counterfactual language distribution, so the entire prompt without the part that we want to actually focus on. And then we have this weighting factor. Please see the paper for more of a derivation of how this is, how we formulated this. We specifically tested this in the following scenario, where we have system level prompts and user level prompts. So this represents the two-part prompt here. And we want to generate a completion that maybe pays more attention to the system level prompt. This is really important in jailbreaking scenarios, for example, where users might maliciously try to override the system prompts. Overall, we found that CFG improves the performance across a range of different tasks, and the performance increases are roughly equivalent to using a language model that is twice as large as the original language model. So the result that this has is that even though our inference technique requires 2 passes through the language model, one to achieve the the prompted distribution, the other to achieve the unprompted distribution, we are still able to perform comparably well with models that are twice as small. Finally, we found that humans preferred the controlled responses. So humans prefer responses that pay more attention to the system prompt across all levels of gamma, showing that this is a highly generalizable procedure, and any kind of shift you can do to the distribution will have a positive effect on the outcome. This work was incorporated into major open source libraries like Hugging Face. So this is one of our co-authors, Vermeil, and llama.cpp. And so it's broadly in use by the open source community. Okay, so thank you for your time so far. We've come to the end of the material part of this presentation. What are the future directions here? So there's future directions within computational journalism that I'm really excited about. In this paper that I showed at the beginning, we not only talked about sourcing, but we talked about other parts of the news production pipeline. So sourcing is what we focused on this entire time, but there are many other components to producing a story that we want to apply similar logic to. We then have grants and submission to actually operationalize this research. So we would love to actually bring it in front of real users. Next, slightly outside of just professional journalism, there's no reason why our techniques cannot be applied to a broader domain of information sharing. So in our work, we compared model recommendations to human actions, but we can take a very similar technique to compare malicious human actions to professional human actions. And this would be building off work that I've done at Microsoft Research with Eric Horvitz. Stepping even further away from journalism, as I mentioned before, this is not just a story about journalism, right? We can generalize the production of news to a generalized state space and the inclusion of sources to some kinds of generalized action spaces. I mentioned in the beginning that reading, we all have the experience of researchers of reading scientific literature and trying to infer, kind of read between the lines to understand what the omission of certain results mean, or for example, specific hyperparameters probably imply that the researchers did larger sweeps of hyperparameters. So there's all these ways that we are familiar with reasoning about human actions. And we're working, as I said, with OpenAI in the science domain, Ulether in the music domain, and others in these different domains. Outside of these fields, I'm also working in social media and nuclear fusion. And we are bringing this into a larger body through a tutorial at NACL 2025. Okay, thank you so much for your time. At this point, I'll take questions.
Yeah, so I've got one, Alex. I was wondering if you could explain a little bit more about what the kind of like 1 to 5 scale for creativity means and what each point on there would be.
Yeah, definitely. So we had a codified schema that we gave to our annotators. Let me just jump to that slide. Whoops. Okay. Like I mentioned in the dataset was comprised of press releases that were ultimately covered by news articles. So the press release gives us a starting point. In this example regarding today's jury verdict, is a press release by Tesla, and it's describing kind of these events and Tesla's own take on these events. If you were not spending a lot of time thinking about how to cover this and thinking about which direction to cover this in, you might simply build off of what Tesla released and you might simply like choose maybe like a jury member, or choose a spokesperson for Tesla, someone who's going to be very kind of close to what Tesla is originally describing in their press release. However, what journalists end up doing a lot is reaching further for the bigger picture, or a comparison, or something that actually goes in a different direction than the starting point. So that formed the basis of what our creativity measurement was. Um, we defined like a 5 on the creativity scale as a 5 was defined as this source is in a significantly different direction than the original press release. It's a significantly new idea that is not included in the press release or easily derived from the press release. And on the other end, a 1 is like, this is patently obvious from the press release, or like if you thought about it for a second, you might reach for that source based on what the press release said. A 3 is somewhere in the middle, so it's still kind of derived. It's still kind of similar to what the press release is saying, but it's like it's taking steps away and in a broader and newer direction.
Okay, yeah, that helps. Thank you.
Mhm.
I think John has a question.
Yes. So in your last section, when you were talking about classifier-free guidance, I was reminded of what we used to do in the pre-neural n-gram language modeling days, where we would just back off of context in order to get a more robust probability distribution. Um, is that an accurate metaphor here? I'm not sure if you could say that, and I guess I have some follow-ups about the classifier-free guidance section.
Yeah, can you define what context means in the setting you're talking about?
On the Ngram days, you would just be like, I want to predict a word given the previous 4 words, and sometimes you don't have. This is non-neural, so you don't have an actual experience of seeing those previous 4 words, and you say, okay, well, what about the previous 3? What about the previous 2? What about the last one? Well, I haven't even seen that. Okay, what's just the unigram probability of the token, and you essentially merge that back off together. So you're doing the same thing because you're backing off from the prompt, right, and the context. But in this case, you're only doing some of the back off. You're backing off of the prompt, right? You have that luxury, and as a way of enhancing robustness. So I'm wondering if that's basically what's going on here.
I think so, except it's like a lot softer, right? Like we're not just
Oh, sorry.
backing.
I should say the back off was done softly as well. So you would learn a lambda relationship between all of these things, and then the actual n-gram context probability was the smoothing of unigram and bigram and trigram and 4-gram probabilities.
Right. Yeah, you could make that connection.
So in this case, I wasn't clear on how you actually determine what the interpolation weights are. Can you show the slide again?
Yeah, sure. It was it was task and it was task dependent, and it was just a hyperparameter sweep. But yeah, sorry.
Sorry, you would just set the hyperparameter. Um, you're just fully backing off the prompt, right? Or fully incorporating the anti-prompt.
Yes. Well, I mean, gamma we've tested from a lot of different ranges.
There's one gamma.
Yes, there's one gamma, and you can set it to, that's a real value number, so you can set it to whatever you want.
Okay, and so you just swept across for the task on the training data.
Yes. I mean, in general, yeah. So here's like a visualization of what a hyperparameter sweep might look like. So in general, we found that like certain values tended to continue to be optimal. So like 1.5 was kind of the optimal value in like most settings. In the negative setting, it was a little different. So the values were a little bit higher. You can see that they range higher. It's like up to 6. But we caution in the paper that there's not really a global optimum that we found. So it is kind of test dependent.
Following up on that, what does a negative prompt mean? I feel like that's not always definable.
Uh, so yes, so the negative prompt means what, in our case, it means like what you don't want to be paying attention to. So here is a two-part prompt where we have a system level instruction and then like a user level prompt. And we define the system level prompt as the positive prompt and the user prompt as the negative prompt.
Hmm.
So we wanted to be paying more attention to the system level prompt than we wanted to be paying to the user prompt.
So it's really not, it's just a different, it's just a secondary um, set of instructions, essentially, right?
You mean this
The notion of negative, I mean, there's not an actual semantic negative associated with that in that case, for sure, right?
yeah, we could call it something different. We certainly could. We called it negative because in the literature, similar formulations are used in computer vision to specify actually like what you don't want to be doing.
Right, but you're not saying you don't want to be doing it in this case, right? You're saying I want to do this and I want to do this, right? And, but
Yes.
okay,
Yeah.
understand.
Yeah, exactly. This helps us get different balances of what we like actually want to be doing.
Looks like Moshe has her hand up.
Moshe?
Yeah, I also have a question, Alex, and thanks for the great talk. So, in your experience, and at a higher level, I'll mention why I'm asking this. First of all, do you see any benefit to training, to having somehow training or post training a separate plan generation model and then a different model that is better at following plans? That's my first part of the question. And then my second part, which is really a higher level question, is that with these patterns, with like in policy, off policy stuff that we have been seeing, do you think there's a concern that if another model plans better, like generates a better plan, is it necessarily the case? Basically, do models adhere better to their own plans than plans generated by other models?
Yeah, those are super interesting questions, Moshe. Thank you so much. And the short answer is that our approach was resource constrained.
Mm-hmm.
So we were training these auxiliary planners in these lower dimensional action spaces simply because we didn't have the resources to fine tune a large language model and do like O1 style training.
Mm-hmm.
And also like CFG is an inference time technique, which again doesn't require fine tuning or training. So I'll answer kind of the CFG part first. I definitely think that CFG is a great technique to just generate lots of synthetic data that we then go and fine tune a model. I think
Mm-hmm.
it's like I would love to do a follow-up where I just like where we use this inference time technique, which is pretty expensive because it requires multiple runs of the model to generate like a great data set that then we can kind of bake it into the language model. We haven't tested that yet, but I think that it seems very reasonable to me that would work. The question about like whether the same model that generates should also be planning is, I think it's a really open question. So obviously with O1, the generator is also planning,
Mm-hmm.
but I I think it's unsettled. I mean, how often do plans occur in a purely lexical space? How often does training a model to become a planner actually reduce your abilities to do all these other tasks like adhering to plans? Um, I'm a little more skeptical because I feel like as humans, these cognitive processes are very separate. Like,
Mm-hmm.
you know, I think about prefrontal cortex as like the planning center, but like the language center is like different. So, um, so I'm a little bit more skeptical, but I definitely think that that's an area of exploration. I would make a little side note that like, um, these creative tasks are in kind of a different domain than O1 style planning because like
Mm-hmm.
O1 style planning is usually optimized towards like a correct factual answer.
Hmm.
Whereas these creative tasks are a little bit looser. They're a little bit more reliant on, as Jay was saying in the beginning of the talk, like a more loosely defined reward function.
Yeah. Yeah, I think like the key word in your like response and talk is like creative tasks, because like what would you, for example, plan a novel and then give it to write to someone else? Whereas like if you like, let's say non-creative tasks, like for example, humans can follow manuals like assembly manuals, which is like planned by somebody else, but like then stored somewhere to be reused by many humans. So I guess I was thinking about like maybe a non-creative scenario where we can generate a plan once, but then use it multiple times instead of like having each model like do the inference basically to generate the plan.
Yeah, that makes a lot of sense.
Yeah. But yeah, thanks so much. I really liked your talk and how it was structured.
Oh, thanks, Moshe. Appreciate that. Still a lot of work to be done on the slides.
I think we're about at time. So I'm not seeing any other questions at this time. So thank you, Alex, so much for your talk, and good luck on your job talk next week.
Thanks. Yeah, I'm dropping my email in the thread, so those of you that don't already have access to it, feel free to reach out. Comments, criticisms, or just follow-up questions or anything you follow-up collaboration requests or anything, please hit me up.
Yeah, thank you so much, Alex.
Okay, see you guys. Thank you.